Solution concentration calculations 2. Percent concentration and molality is what we're looking at. Okay. Now, molality is different than molarity. Molality has, first of all, a lowercase m. It's also in italics. That's the symbol instead of molarity, which is a capital M. Molality and molarity both look at moles of solute, but the difference here is the denominator. In molarity, you're looking at liters of solution. In molality, we're looking at kilograms of solvent. So you have to be real careful which unit or which expression of concentration you're looking at. So in this problem, we're going to take and figure out the molality of a solution. So it says in a lab, a student adds 4.5 grams of sodium chloride to 100 grams of water. Calculate the molality. So we're going to still figure out what's the solute, what's the solvent, and what's the solution, and what information do we actually need for this problem. So first, the solute is the one that you have the least of. That's sodium chloride. Okay, which are the solid in this case. Water is a good indication that we're going to have water as our solvent. So solvent is 100 grams of water. Now in molarity, we didn't really need to know about the solvent, but because we're looking at molality and it's kilograms of solvent, then we definitely need to use that. For the solution, we just need to know its molality. For sodium chloride, we've got it in terms of grams, and up here we're looking for moles of solute. So we want to change those moles of solute in grams of solute into moles of solute. For the solvent, we've got grams of water. Well, we want our solvent to be in kilograms of water, so we're going to change that into kilograms. Let's do that. 4.5 grams of sodium chloride. We're going to figure out the molar mass of sodium chloride. 1 sodium, 1 chlorine adds up to 58.44 grams for every 1 mole. Cancel my units, and I end up with 0.077 moles of my solute. Now for our solvent. We've got 100 grams of water. I know that in 1 kilogram there are 1,000 grams. I'll use that to convert grams into kilograms. 1 kilogram, 1,000 grams. And that makes it 0.1 kilogram. Then the only thing we have to do for molality is divide. So we'll take the moles, which is 0.077, divided by the kilograms, 0.1, and we end up with a 0.77 mole per kilogram solution. That's its molality. So we could also write this as 0.77 with the lowercase m. And that's our answer. What does that lowercase m stand for? It is the molal concentration. You need to note that, I'm not going to do an example, but just like we did with molarity, you can use molality as a conversion factor. So if I were to read the answer that I have here, the 0.77 moles per kilogram or 0.77 molal, we would take and use it like this. For every 1 kilogram of solvent, I have 0.77 moles of the sodium chloride solute. Okay. The second one we're going to do is percent concentration, and they come in multiple forms. You can have percent by volume and percent by mass. In both cases, you're taking the solute and dividing it by the solution. You need to remember that solution is a combination of solute and solvent. Okay, so here's our first example. What's the percent by mass of sodium chloride if there are 15 grams of sodium chloride in 15 milliliters of water? This one's a little tough. We have about the same amount of solute as we have solvent. Which one is which is important. It's water. So water's our universal solvent. Water's definitely going to be the solvent. Sodium chloride is a solid, so it can't dissolve anything. It has to be our solute. So we'll take 15 grams of sodium chloride as our solute. 15 milliliters of water. Now, 15 milliliters of water, we can change that into grams of water by knowing the density of water. I know that for every 1 milliliter of water, I have 1 gram of water, and what I'm looking for in this equation is a mass of solution. If I was looking for volume, percent mass by volume, then I would put volume down there, but we're looking for mass. So for the solution, now I don't have any information for the solution, but I can figure out the mass of the solution because the solution is the solute plus the solvent. So I'll take the 15 grams of sodium chloride and add them to the 15 grams of water, and what I find is that we've got 30 grams of solution. Okay, now just to figure out the percent mass by mass, you're going to take the 15 grams of solute, that was the sodium chloride, divide it by the 30 grams of solution, right, all of it together, and multiply it by 100 to get a percent. Notice we're taking the part that's the solute, the part over the total, that is the solute plus the solvent, to get a percentage. And that's going to be 50%. Second example, what's the percent volume per volume of a solution made by mixing 22 milliliters of alcohol with 125 milliliters of water? Let's see, which one is the solute, which one the solvent? Well, both of these are in terms of milliliters, so they're both liquids. So one thing we can do to figure out which one is the solute and which is the solvent is by the amounts. Since we have less alcohol, that's going to be our solute, 22 milliliters of alcohol. For our solvent, we're going to use the water, the one that we have the most of. And for our solution, we're just going to add those two, the solute plus the solvent, to get the volume of solution. And that works out to be 147 milliliters. Okay, pretty quick and easy. We'll just take the percent volume by volume is going to be the volume of the solute, that's the alcohol, the 22 milliliters, divided by the total times 100, and we get 15%. Oops. Okay, that one should be pretty simple. They do get a little bit tougher in the next problem. Example 3. What volume of isopropyl alcohol is used to make 500 milliliters of rubbing alcohol? Now, if you've ever looked at the concentration of rubbing alcohol, it says 70%, and that's volume per volume. So our solute, well, we're going to look at how much isopropyl we'll need. That's the solute. The solvent, it pretty much just probably going to put it in water, but not really necessary since our equation is solute per solution, and we have the amount of solution. We don't necessarily need the solvent when we have the amount of solution. So the amount of solution is 500 milliliters, and that 500 milliliters, we want a 70% solution. Okay, so we're just going to plug things in and figure out how this works. So 70% is going to be equal to X milliliters. I don't know the amount of isopropyl that I need. Over, we're looking for a total volume of 500 milliliters times 100. Okay. Now 70% is really like saying I have 70 milliliters of isopropyl for every 100 milliliters. Or I can think about it this way. If I want to move this over, I can divide the 70 by the 100, and so that would look like this. For every 70 milliliters, I have 100 milliliters of total solution. That's going to be equal to the X milliliters of solute over the total solution. Okay, and we can multiply both sides by 500, move this one over here on the top to get it solved for X. So 70 times 500 divided by 100, that's on the bottom still, is equal to the amount of solute that I need. So when I calculate that out, I get 400 milliliters. So it will take 400 milliliters of isopropyl alcohol, so that's pure isopropyl alcohol, to make a 500 milliliter solution that is 70%. Okay, there's another problem that's just a little bit trickier, and that would be when you're finding the solvent, and you'd have to use X for the solvent, and you'd have to use a little bit of algebra to figure that out, because your solution would be solute plus solvent. So I can help you with those problems tomorrow in class.